Hello, this will be an IBEW algebra and function practice exam mode 2. So this is not timed. So this is yeah, an IBEW algebra and function practice mode exam. And this is the second one. So let's start again. So let's start with question one. So question one is a sequence number, and the first number is 50, 26, 14, 8, and 5, right? They want to know what would be the next number. So you kind of have, it is a sequence, and we kind of have to figure out a pattern. You can either have a common difference, right? You can also have a common ratio. So you're either adding or subtracting or a common ratio. Um, Ratio is when you multiply a number, and believe it or not, you can also have a mixture of both. Okay. So if you look at the number 1526, what did you have to yeah, what did you have to so I think we could subtract. I believe you would have to subtract -24, right? And then keep on going. 26 to 14, it looks like you had to subtract 12. And then 14 to 8, it looks like you had to subtract 6. And then 8 to 5, it looks like you have to subtract 3. So look at the pattern. From 50 to 26, you had to subtract 24. And then from 26 to 14, you had to subtract 12. What are you doing with the difference? It went from -24, -12, -6, and -3. So yeah, what do you think's happening? Yes, you're taking half of the difference. So for -24 to -12, you had to divide it by 2, or you're taking half of the difference. So so if you look at the last difference, we subtracted 3. So if you take half of that, it would look like you're gonna have to do -1.5. So what is 5 minus 1.5 without a calculator? Um, it looks like it's going to be 3.5. Okay, so your answer will be 3.5. Well, it wasn't too bad. They get a little bit more trickier. So let's move on to question two. Let's see, question two. Oh, this is still question one. Question two says, what is the next number in the following series of numbers? So we're dealing with sequences. So our first number is 39, second 27, 18, 12, and 9. So let's see if we have a common difference. From 39 to 27, it looks like you had to subtract 12. From 27 to 18, it looks like you had to subtract 9. And then from 18 to 12, it looks like you had to subtract 6, I believe. And then 12 to 9, it looks like you had to subtract 3. Now, if you look at the patterns, we want our differences. We want from -12 to -9, -6, and -3, right? There's not really a much difference. I mean, there's no real pattern. Um, Actually, there is. From -12 to 9, what did you have to add to get to 9? It looks like you had to add 3. From -9 to 6, what did you have to add to get from -9 to -6? Yes, it looks like +3. And then from -6 to -3, it looks like you had to add 3. So it looks like you're adding 3. You're gonna have to add 3. So the next difference is you're gonna have to add, what's -3 plus 3? 0. So you take the last term, 9, and then you add 0, which is 9. Okay, so that it is 9. Okay, so that was question two. Question three says, what is the next number of the following numbers? Okay, so question three, let's see. We went from 4, 7, first term, 4, 7, 8, 11, 13, and 16. So from 47, I believe you had to add 3. From 7 to 9, it looks like you had to add 1. I don't think you I don't think you can multiply anything, right? And then from 8 to 11, it looks like you had to add 3. And then from 11 to 13, it looks like you had to add 2. And then from 13 to 16, it looks like you had to add 3. Okay, that looks like a really horrible mess. Uh, there's really nothing like, there's not an exact pattern. You went from 3, 1, 3, 2, 3, right? There's not a good pattern. But if you look at it more carefully, what do you see? I see there's a number that's constant. This 3 and 3 is constant. So, and then this 3 and 3 is a constant. Now, if you look at the number in between it, it's a 1 and a 2. So, yeah, what's happening? It looks like every other number is you're adding 3, and then it looks like you're adding one of the yeah, every other number you're adding 3, and then after that you're adding 1. So we went from 3 to 3. So it's not going to be 3 because it's every other number. But if you look at the previous number 2, it looks like we're adding 1, right? Because if you look at 1 to 2, you had to add 1. So it might look like we have to add from 2 to, if you add 2 to 1, that's 3. So what you do is you're going to add 3 on the next number. So it's going to be 16 plus 3, which is 19. Okay, so that is letter 3, question 3. And yeah, I understand it is difficult to do these problems like in a minute. So yeah. And no, I did not, I'm not just doing, this is not my first time. I had to do this before I did the video. So yeah. So don't worry if you don't get it first. Just watch the video. Okay, question 4. What is the next number in the following series of number series? In question 4, we went from 1, 1, 2, 4, 6, 18, and 21. Okay, that looks weird. Question 4. Let's see. Let's try if we can see any common difference. So from 1 to 1, it looks like you had to add nothing, right? You added 0. From 1 to 2, it looks like you had to add 1. And then from 2 to 4, it looks like you had to add 2. And then from 4 to 6, it looks like you had to add 2. And then from 6 to 18, it looks like you had to add 12. And then from 18 to 21, it looks like you had to add 3, I believe. Okay, that's not good. It does not look like it. It doesn't look like a pattern that, a good pattern, right? Hmm. Let's see if we could find a common ratio. So can we think of a number? So let's go on the top and then let's try to find a common ratio, meaning a number that's multiplied. So from 1 to 1, it looks like you had to multiply by 1, right? And then from 1 to 2, no, there's no common ratio. There's no yeah, but from 2 to 4, it looks like you could multiply it by 2. 4 to 6, there's no common ratio. but 6 to 3, it looks like you multiplied by 3. So now I see the pattern. If you look at this like this way, these numbers stay the same, and then so this number stays the same. So it looks like the pattern is you multiply by 1 and then you add 1, right? And so wait, you multiply by 1 and then you add 1 and then you do the same. And then the next number is multiply by 2 and add 2. So if you look at the pattern, these are the same, these are the same, and then these are the same. So yeah, it looks like the first part was you multiply by 1, then add 1. Yeah, that looks right. 1 times 1 is 1, and then if you add 1, that gives you 2. And then if you look at this, then if you look at the other one, so over here, it looks like you multiplied by 2, so multiply by 2, then add 2. And then the process continues. So then you multiply by 3. So the next one is you over here, it looks like you multiply by 3, and then add 3, right? So 18 to 21, you add 3. Okay, so I see multiply 3, then add 3. Now, what would be the next one? I guess you're gonna have to multiply by 4. So the next one is we're just gonna have to multiply by 4. And that's it. We don't add 4 because they're asking for this number. So for the 21, you're gonna have to multiply by 4 and you get 84. So the next term is 84. Question 5. Another sequence, -1. Our first term is -1, +2, +1, +3, +4. So let's start with see if we can deal with differences. So from -1 to 2, it looks like you have to add 3. From 2 to 1, it looks like you're gonna have to subtract 1, right? And then from 1 to 3, it looks like you have to add 2. And then 3 to 4, it looks like you have to add 1. Yikes, there it looks like there's no pattern, but if you look at this closely, this lines with this one, and then this two lines with this, right? So I think it's a Fibonacci series, right? So it is a Fibonacci series. So okay, so uh, can't say it real well. So this is from here to here, you add 3, from 2 to 1, subtract 1, from 1 to 3, you add 2, and then from 3 to 4, you add 3. Wait, you add 1. So over here, okay, so this one, you add 3, but this is -1. And then over here, you add 2, and then this is aligned with this. So what's from 2, wait, Sorry, this is a plus 3. So from 3 to 2, it looks like you're subtracting 1, right? So wait, so over here, from -1 to 2, you add 3. And then this negative number, this -1 is aligned with this one. And then from the next one would be plus 2 because this is aligned to this. So this one is this, and then so it looks like you're subtracting 1. So I think you're gonna have to, the next number would be plus 1, right? Because we went from 3 and then -1 to, and then this is aligned with 1. So from 2, I think you have to subtract 1, so that's why it's a plus 1. So the next number would be 4 plus 1. No, I think it's going to be 4 plus 3, right? Oh, I see. Okay, now I see the pattern. So this one was plus 3, and then you had to add -1 because -1's aligned to the previous number. And then over here, this is 2 because it's aligned with this number here. And then you add 2 plus 1, that's 3. So it's going to be 3 plus 4, right? Because this next number is aligned to this one. So it's going to be 4 plus 3, which is 7. Wait, no, no. Oh, no, I'm making this harder. This is this number should be aligned to this. So the next number is actually plus 3. So the next number is the last term, which is 4 plus 3, which is 7. Okay, because you see the pattern, this -1 is aligned to this, so it's every other number. So this number here is aligned with this. So this one is, you're gonna have to add 3, not 1. So 4 plus 3 is 7, so that is 7. Okay, move on to question 6. We have ones, our numbers are 1, 4, 9, 16, and 25. Oh, what can we do? Hmm. So from 1 to 4, it looks like you have to add 3. From 4 to 9, it looks like you have to add 5. From 9 to 16, looks like you had to add 7. And then from 16 to 25, it looks like you have to add 9. But what is the pattern? 3, 5. Oh, this one's not too bad. It looks like you're adding 2 for each differences, right? From 3 to 5, you had to add 2. From 5 to 7, you had to add 2. From 7 to 9, you had to add 2. So the next number is, you're gonna have to add 9 plus 2 is 11. So it's gonna be the last number plus 11, which is 36. Okay. Okay, so in this one, we have a system of equation and we need to solve. So there's two ways you can do this. You can test it out, right? Test each values out. Like plug in each value. So if you plug in 1, 5, you have to test in both equation and the left side equals the right. That means it works. But it's so time consuming and you have a time limit. So you can just solve this using algebraically, more specifically elimination. right? So here's system equation. Here's equation one, equation two. We're going to do the elimination process. So what letter would you like to get rid of? It really doesn't matter. There's no easier one, right? I would get rid of oh, one other problem. What do you see? They're not aligned correctly. So let me align them correctly. So the first one, I'm going to align it as 5x minus 2y equals -7. And then the other one, I can rearrange this. It doesn't change the problem. So this would be, just make sure the letters are lined up. -5x plus y, 6, right? Here's equation one, here's equation two. Now, do you see that there's a letter that cancels immediately? That would be the x's. So usually with elimination, to get rid of a letter, you have to multiply one or both equation by a number, but the x's cancels immediately. So if you add them up vertically, the x's cancels. What's -2y plus 1y? Negative y. What is -7 plus 6? -1. Solve for y, so you're going to divide both sides by -1. So you get y equals 1. Now, how do you solve for x? You're just going to put the x. To solve for x, you're going to simply put in y into either the first one or the second one. It doesn't matter as long as they're original. So I'll put it in the first one. So it's 5x minus 2 times 1 equals -7. So that's 5x minus 2 is -7. Solve for x, you're going to add 2, you get 5x equals -7 plus 2 is -5. And then divide this by 5. And then you get x equals -1. Okay, so it looks like our solution is negative x is -1 and my y is +1. So it's this one. Yep, so that's how you solve it using elimination. Whoops. Let's move on to question 8. So factor this polynomial. Yeah, so how do we factor polynomials? So think of it, okay, think of this. Yeah, so what it will do is this is one term. We have x5 y squared z6 minus x cubed y squared z7. Think of this as one whole term and this as one whole term. So let's start with the letter z. What is the largest amount of z's that we can take out evenly? So the largest amount of z's we can take out evenly. So over here we have a z6, and then over here we have a z7. So the largest amount of z's we can take out evenly would be z6, right? From both of them. And then what about our letter y square? We have a y square here and a y square there, so the largest amount of y's we can take out evenness. And then x cubed. I mean x's, we have x5 and x cubed. So the largest amount of x's evenly would be x cubed. Okay, so we still can't change this problem, so um let me rewrite this. Let's put the x first, so it would be x cubed y squared and z6. Okay, so let's start with, we can't change the problem. So what do we have to multiply x cubed to get x5? X2. Why did I use an x2? Because remember when you're multiplying with the same base, for example, x3 times x2, you add that power. So this is x5. Right? So when you multiply, you're really adding. So I put an x2 here, and then on the first, looks like we don't need any more y's, so we're just gonna leave that blank. And then for the z's, how many z's do we need? None, right? None for right now. Now, if you look at the second term, yeah, if you look at the second terms, we need a negative x cubed, a y squared, a z7. So it looks like we're gonna need a minus, and I don't think we're gonna need any more x's. I don't think we need any more y's, but we do need the z's. How much? One z, because remember when you multiply z6 times z1, you add the exponent, so that's z to the 7th. Okay, so that is your answer. So it's x cubed with y squared is 6, x squared minus z1. That would be x cubed. The last one. Okay, let's move on. Question 9. So factor the polynomial. So yeah, there should be, if you forget how to factor completely, there are different kind of rules of factoring, but this one we're gonna do simple factoring. I call it simple factoring or the X method, your teacher might call it. And the reason why I call this simple factoring is because the A value is 1, right? If it's other than 1, so if there was a 2 or 3 in front of the X, you would have to try bottoms up. So if we're simple factoring, write out your two parentheses, and then I'm going to put an X here and an X here because when we FOIL it out, we want an X squared, right? And then this is a tricky part. So you have to come up with two numbers that multiply to positive 4. And when you add it, gives you negative 4. So what is that going to be? Two numbers that multiply 4, and when added, gives you negative 4. So I think there's only one choice. It would be negative 2 and negative 2, right? Because what is negative 2 times negative 2? Positive 4, right? We want positive. And then what is negative 2 plus negative 2? Negative 4. Okay, so we're going to put a minus 2 here and a minus 2 there. Now, you don't see our answers because we have a repeat, so you can rewrite this as x minus 2 squared. So this one. Question 10. Turn the following. So now we're going backwards. We're not factoring, we're good at FOIL. Turn the following expression to a simple polynomial. So they want you to FOIL this out, collect like term, etc. So let's start with here. What is 4 times negative x squared? Negative 4x squared. What is 4 times negative 1? Negative 4. What is negative x squared times 2? Negative 2x squared. And what is negative x squared times negative 6, 1? So I know that two negatives becomes a positive, so that's 6. And then it's going to be x cubed because x2 times x1. Remember when we're multiplying with the same base, you add them. So it would be x3. Okay. Then what you do is put it in order, or collect like terms and put it from highest to lowest. So our highest power is x cubed, or this 6x cubed, right? So that's going to be 6x cubed. And then the next one is x squared. I see a negative 4x squared here and a negative 2x squared there. So that's going to be negative 6x squared. And then my constant is negative 4. So that would be what? It's like the last one. Simplify the expression. So just like this other one, we gotta FOIL it out and collect like terms. Let's show it. So go ahead and FOIL it out and collect like terms. So over here, what is x cubed times x cubed? X6, right? X cubed times x cubed is x6. What is x cubed minus x squared? That's minus x5. And then what is 2 times x cubed? That is 2x cubed. What is 2 times negative x squared? That's negative 2x squared. And then bring down the minus x cubed plus x4. Then it's all about collecting like terms. So my highest power is x6. I don't see any other. The next one is 5, power 5. I don't see any other. The next one is x4. The only one x4 I see is this x4. The next one is x cubed. You have a 2x cubed and a negative 1x cubed. So that is positive 1x cubed. And then the next one is negative 2x squared. So that one would be, which one would that be? This one. Yeah. Okay, let's do question 12. Consider the following formula. AB equals A plus B plus 5. And if B equals 4, which of the following statement must be true? So this is question 12. So what I would do is I would plug in 4, B for 4, right? Plug in 4 and into the equation and then solve for A. So this one I wouldn't graph. I don't even know if this is linear or not, but I would not graph. So I would just plug B equals 4, solve for A. So this is going to be 4A equals B equals 4. So it's A plus 4 plus 5. So that's going to be 4A equals to 5 plus 4 is 9. So it's A plus 9. And then what you want to do is solve for A. So let's get all the A's on one side. So I'm going to subtract A, subtract 1A. And I get 3A equals to 9. And then I'm going to divide this by 3 because I want to solve for A. So A is going to be 3. Okay, so if A equals 3 and B equals 4, let's plug it back into each statement. So now we know that A is 3 and B is 4. Let's test each one. So is letter A true? Is A greater than B? So is 3 greater than 4? Completely false. What about letter B, does A equals B? So does 3 equals 4? No, that's definitely false. What about C? A minus B equals 0. So A is 3 minus 4. Is that greater than 0? 3 minus 4 is -1 is greater than 0. Is 0 greater than -1? I don't think so. You have 0, here's -1. Is -1 greater than 0? False. What about D? It has to be D. So B minus A, so that's 4 minus 3 is greater than 0. What's 4 minus 3? 1. Is that greater than 0? Yes. So the last statement is true. Consider the following formula: m plus 2n equals 0. Which of the following statement is true for this formula? Um, let's wait. So if I solve for m, so if I subtract 2n from both sides, so you get m is equal to -2n. Um, then from here, yeah, I think, I mean, you could plug in values. M is always greater than n. That could be false because n can be negative, right? So that could be false. What about B? M is always lower than n. Not true. N can be negative, which makes it positive, so that could be false. C, is M always equal to n? No. Not even, not always, right? I mean, you could plug in n for 0 and n equals 0, but that's the keyword always. No, not always. What about D? M may be greater than or lower than n. That is a true statement, right? Because n can be positive or negative. It could be lower or below. It could be greater or lower than n. So I'm going to say D. Let's do question 14. Consider the following formula: S equals n over 2 plus 8. So on this one, this is question 14. This is definitely a linear equation problem, and I definitely would graph this. It wouldn't work if you plug in values because it could be true sometimes. So that's yeah. So what I would do is what would I do? So this is a linear equation problem. So when you're dealing with a linear equation on this test, it's best to draw it. Let's rewrite this. I mean, n over 2, that lot, I don't like that. Did you know n over 2 is the same thing as 1 half n? Yes, you could put the n either on the top or the center, but never on the bottom. Now, this is definitely a linear line, and I know because it's the form of y equals mx plus b. The only difference is our y is not y, our y is s. So our y is our s, and our x is not x, it's n. Okay? So if you want to draw it, draw your Cartesian plane, label it correctly. And, oops. This we said x is n, so this should be n, and then on the y-axis it's s. So how would we graph this? So you can graph this using the rise over run method, right? Figure out your slope, which is 1/2, and figure out your b, which is 8. But I don't want to do that. I want to just graph it, finding the x-intercept and the y-intercept. I think that'd be a lot easier. So we kind of already know our y-intercept. Our y-intercept is your b value, which is 8. So our y-intercept is 0.8. What about my x-intercept? How do you find the x-intercept for any graph? You simply set y, or in our case, it's s, to 0 and solve for n. So 0 equals 1/2 n plus 8. Okay, and then let's see, we can get rid of the fraction, multiplying everything by 2. So 2 times 0 is 0. 2 times 1/2, the 2's cancel, so you're left with n plus 2 times 8 is 16. And then subtract 16, yeah, n equals -16. So it looks like our x-intercept is at -16. So let's see here. So this would be on the x-axis, you can go by 2s. I think that would be more appropriate. So this would be -2, -4, -6, -8, -10, 12, -14, -16. So you can have an intercept here. And then on the y-intercept, you can go by, it's up to you, you could go by ones or twos. So if we go by twos, it would be 2, 4, 6, and 8. So go ahead and dot it, and then dot these 2 points. Okay, so now let's test each value. So is the first one correct? When the value of n, so n is our x, is less than -16. So here's our x. And if you go below -16, s is positive. I think that's false. So if you go starting with -17, right, yeah, this is wrong. The x value is starting to become negative, so that's false. What about b? The value of n is greater than 16, s is negative. So the value of n, so n is our x, greater than 16. So here's 10. So let's pretend, yeah, this extends, and let's pretend it's 16. So it looks like greater than 16, it looks like the s is positive, right? So greater than 16, so like 17. So if you plot 17, the y value is positive. So that can't be true. What about C? The value of n, when the value of n is greater than -16, s is negative. When the value of n is greater than -16. So here's -16, something larger, so maybe -15, -14. S is negative. That's not always true. Maybe, no, that's actually positive, right? If you look at -15, it starts to become positive. -14, it becomes positive. No. What about D? When the value of n is less than -16, so that means -17, s is negative. Yes. Here's -17. What is the y value or the s value? Negative some number, right? So it's this one. Okay, let's move on to 15. Which of the following graphs represents this graph y equals negative 2x plus 3? So there's a lot you can eliminate. In this graph, I know the slope is negative 2 and my b is 3, right? So, which you can eliminate. So which one, actually we could find it now. Which one has a y-intercept of 3 and a slope that's negative 2? So here's one has, I think it would be graph D, right? This has a y-intercept of 3 and then the slope is negative. So yeah, I think it's graph D. So this is question 15. Yes. So it's that one. So on the test, you really want to do some kind of elimination, right? To save you more time. Okay, 16, consider the following formula. ABC minus 4 equals A times B plus C minus 1. If B equals 2 and C equals 3, oh, what is the value of A? So this one, it's really simple. It's not a linear equation. You just plug in the values and solve for A. So let's do that. So B is 2, so it's going to be, oops, it will be A times B, which is 2, and my C is 3, minus 4 equals to A times B, which is 2, plus C, which is 3, minus 1, right? So let's go ahead and clean this up. So let's do order of operation. We must do, on the left side, you should do the multiplication first. So, right, pandas, do the multiplication. So, because we don't have parentheses or exponents, so we must do the multiplication. So 3 times 2 is 6, and then you have the A and then minus 4. You cannot combine them, so just leave that negative 4 alone. On the right side, what I would do first is do the parentheses first because order of operation. You have a P, so you got to do the parentheses. So you're just going to do 2 plus 3 minus 1, which is 4. So that's going to be 4A. Okay. Then what I would do is move this negative 4 to the right by adding 4. And then I'm going to subtract 4A. Okay. So 6A minus 4A is 2A. And then this is going to be 4. Solve for A by dividing both sides by 2, and you get A equals 4 divided by 2 is 2. 17. Um, Consider the following formula. 5 times A plus B minus 3 equals C times B plus C. Just like the other ones, plug in your values. For A is 5, C is 2, and then isolate. Yeah, that's the best way or do so. Yeah, 5, A is 5, so it's 5, and then plus B is 3. We'll see. C is 2. And then B is, I don't know. And my C is 2. So on the left side, what I would do is FOIL this out. So 5 times 5 is 25. 5 times B is 5B minus 3. And over here, I'm going to FOIL this out. This is going to be 2B plus 2. let's see. On the left side, you can combine like terms. You can collect 25 and minus 3, which is 22 plus 5b. And then on the right, it's 2b plus 2. Go ahead and solve for b. So I'm going to, I guess I can get subtract 2b, 22, and then what's 5b minus 2b? That is 3b. And then over here is 2. Wait, whoops, I made a mistake here. I didn't FOIL this enough. What's 2 times 2? 4, so there should be 4. And then subtract 22 from both sides. So you get 3b equals to 4 minus 22 is let's go this from 2, negative 18. Divide this by 3. B equals negative 6. Okay, move on to 18. Consider the following expression: a equals 7, c equals 5, and then figure out what you'll get. So, yes, what will we get? Will we get a constant or will we have some letters? So, just like the other ones, it's best to just plug it in. So, let's see, a is 7, c is 5, so it's going to be b, and then c is 5, so it's 5 plus 3 plus a, and then it's parentheses 2 times b minus b minus 5, so b is, sure, minus 5. It's going to be 5 plus 3 is 5, 6, 7, 8 plus, uh, oh, a is 7, so I should replace this a with 7. So it's going to be 2b minus b, and then that's 5. Let's see here. In this parentheses, it looks like you can clean up the b's. What's 2b minus 1b? B plus 5. And then over here you have 8b. And let's see, you're gonna have to FOIL off this 7. So 7 times b is 7b. 7 times 5 is 35. And then you have 8b. So what's 8b plus 7b? 15b is 35. Okay, number 19, consider the following table. Um, the question states, which of the following choices represents the same relationship as is demonstrated in this table? So they give you a table, which one of these makes it true? So is it letter A? Y is equivalent to twice the value of x and a constant, or c equals -1? Um, so letter A, that looks like it's a linear line, right? Yeah, is this a linear line? So let's see. So how do we know based on this table this is a linear line? Um, look at the constant. So over here, I mean, look at the x's. So from 0 to 1, you had to add 1. From 1 to 2, you had to add 1. From 2 to 3, you had to add 1. And then from 3 to 4, you had to add 1. And then 4 to 5, you had to add 1. So they're constant. That's a big sign it could be a linear line. But what about the y's? They also have to be constant. From -1 to +1, what did you have to add? I think two, right? Yeah, and then from 1 to 3, you had to add two. From 3 to 5, you had to add two. From 5 to 7, you had to add two. And then from 7 to 9, you had to add two. Yes. Okay. So we know this is a linear line. So let's find the equation of this linear line. So let's see. Yeah, we're gonna have to find the slope. So I'm gonna pick two random points. I'm gonna use 0 and -1, and then well, you can use any point you like. I'm just gonna use these 2 points. So this is x1, y1, x2, y2. So slope formula, slope is y2 minus y1 over x2 minus x1. So y2 is 1 minus x, y1 is -1, x2 is 1 minus x1 is 0. Two negatives becomes a positive, so that's 2. And then 1 minus 0 is 1. So it's 2. So my equation is going to be y equals 2x. And then my b is already given. It's this value, -1. So we know it's a linear because these are constants. And then, so is it a y is equivalent to twice the value of x? Yes. And a constant where the constant is -1? Yes. So it has to be a. The other is, why is the other false? B is a quadratic, it's not a linear. C is uh way off. It's not, I don't know if that's linear or not. And then D, that's not true. That table does not, if you plug in, if you chug in, yeah, that's not true. So it has to be A. 20. Which of the following functions are equivalent to one another? Okay. Basically, which one of these are the same? Let's clean this up. What about, oh, so what about x plus 2 and b? No, there's no way these two are equal. Even if I factor out a 2, that will not give you, yeah, that's not true. What about c and d? Or let's just look at c. So on the top, you have x plus x plus x. You have x plus 2 all over 2. So that's 2x plus 2 all over 2. And if I divide everything by 2, it's x plus 1. And what about d? Because I don't see that how that's related to a or b, right? So let's do d. So it's negative x is -2x minus 1. And if I fill out this minus, it's 2x plus 1. Um, hmm. Looks like b and d is the one, right? B is 2x plus 1. D, when I clean this up, you get 2x plus 1. So I'm going to say D. B and D. So the last one. Let's see, 21. Y is equivalent to the difference between twice the value of x and a constant c where c equals 3. Oh, they give you an exact equation. Y is equal to the difference. between twice the value of x and a constant, so the minus 3. So somehow that's our equation, y equals 2x minus 3. So which one is that? Is it letter A? So our b is negative 3 and our slope is at positive 2, 1, 2. Right. No, it would be a point should be right there. So it's not that one. Is it B? X is equivalent to the sum? No, it's not B. Ours was Y equals. Is it C? Y equals 2x plus 3? No, ours should be minus 3. Is it D? So that in D, they give us a table, and here's our equation. Y equals 2x minus 3. So let's see if these are true. So if I plug in the input 0, that's 2 times 0 minus 3, which is negative 3. Good. What if I plug in 1? That's 2 times 1 minus 3. That's 2 minus 3, which is negative 1. Yes. And then if I plug in 2, that's 2 times 2 minus 3. That's 4 minus 3, which is 4. Yes. Let's see. 22. Consider the graph y equals mx plus b. Which of the following option is true in regard to this graph? So let's find the equation of this graph. So this is 22. So how do we find the equation of this graph? So let's pick some points. So we have a point here which is 0, 2, and then we have a point here which is negative 1, 0, right? So what I would do is do x1, y1, x2, y2. I'm going to find my slope. So slope is y2, which is 0, minus my y1, which is 2. My x2 is negative 1, minus my x1 is 0. So 0 minus 2 is negative 2, and then negative 1 minus 0 is negative 1. Negative 2 over negative 1 is positive 2. So my equation is y equals 2x, and my b is 2. Is it a? For the function a, y equals negative 1 half x plus 2 have the same slope. No, our slope is 2. This slope is negative 1 half, so it's not a. What about b? The graph of the function is with the same slope, but same and the same interception. No, our slope is positive, this slope is negative. So no. What about C? Y equals negative 2x minus 1 has a different slope. Yes, our slope is positive 2. Their slope is negative 2 and the same interception point. No. Our B is 2, theirs is negative 1. What about D? The graph D of a function has the same slope and different interception. So yeah, that's true. It looks like our y-intercept is 2, their y-intercept is not 2, it's different. But is their slope positive 2 or 2 over 1? Let's see. Go if I pick a point here, if I go rise to 1, 2, and then right 1. Yes. 1, 2, right 1, yes. So it has to be D. Question 23. Consider the following formula: m equals n divided by 1 half. Which of the following statement must be true? Assume m and n are different values than 0. So on 23, what should we do? Let's simplify this. So we have m equals n divided by 1 half. So what is n divided by 1/2? You can rewrite that as n divided by 1/2. So I would cross multiply, so that would be 2n over 1, which is 2n. So m equals, when you simplify this, is m equals 2n. Okay, so we'll just have to test each one. So over here, m times n is greater than n squared. So we said that m is 2n. So it would be m, and then replace that n with 2n. Is that greater than n squared? That would be 2n squared, right? M times, well, hold on. Let me, so in this one, we're going to replace my n with 2n. There we go. So it's 2n times n. Is that greater than n squared? So what's 2n times n? That is 2n squared. Is that greater than n squared? Yes, I think that's always going to be true. I mean, if it's other than greater than 0, so you can't use 0, but if I use n equals 1 and beyond, I think that's always going to be true. Um, so I think it's A. Yeah, I don't think any of these are true. I think if the first one's always true, that means the rest, you can only pick one choice that's correct, so I'm going to say A. 24, consider the following formula: 2a equals 6 minus b over 3, b over 3. Which of the following statements is true? So on this one, what should we do? This one, 24 is, believe it or not, it's a linear line. So when you have a linear line or a linear equation, you should just graph it. Yeah, this is a linear line. So how do I know it? It's really almost in the form of y equals mx plus b. The only thing is you have to get rid of this 2. So if you want, you can get rid of this 2 to make your life easier. So when you do that, you get a equals 6 divided by 2 is 3. And uh-oh, what's negative b over 3 over 2? So that would be negative b over 3 divided by 2. So that would be simplified as negative b over 4. So if you want to, so this simplifies as a equals negative b over 4 plus 3. Okay. Now, you can also rewrite this as negative 1/4 b plus 3. So what I would do is, let's graph this. So be careful. This is our y is our a, and my x is our b. Right, so this right here is very similar to y equals mx plus b. So how would I graph this? I would graph this just using finding the y-intercept and the x-intercept. So it looks like we already have our y-intercept. It looks like it's 3. Because if you plug in 0 into the function, this is going to be negative 1/4, and then replace b with 0 plus 3. So that's 3. So your y-intercept is 3, and then what's my x-intercept? My x-intercept is, we replace a with 0, so it's going to be 0 equals negative 1/4 b plus 3, and then solve for b by subtracting 3. And then solve for b by getting rid of this negative one fourth by multiplying by negative 4. So that would be 12 equals b. So my y-intercept, I mean my x-intercept is 12.0. So if you want to draw your Cartesian plane, that's perfectly fine. Oh shoot. That was a lot of, okay, there's an actually easier way. My b should be 18. So let me clear. You could, I messed up. So I know for a fact this is a linear line because if you divide both sides by 2, it's really in the form of y equals mx plus b. So what I would do is you could just start from here. You don't have to get rid of that 2. How, okay, so just label our variables. So we know that our y is our a. We also know our b is our x. Okay, so let's figure that out. Um, so yeah, y is our a. So let's find our y-intercept. So to find the y-intercept, you simply plug in 0 for x, so 0 for b. So it's going to be 2a equals 6 minus, and then replace b with 0, so it's 0 over 3. So it's going to be 2a equals 6, and then divide this by 2, you get a equals 3. So my y-intercept is 0, 3. Okay, to find the x-intercept. How do you find the x-intercept? You simply replace a with 0. So it's 2 times 0 equals 6 minus b over 3. So it's 0 equals 6 minus b over 3. And then subtract 6. You get negative 6 equals to negative b over 3. Cross multiply, that's negative 18 equals to negative b, and then get rid of this negative by dividing both sides by negative 1. You get b equals 18. Okay, so if you draw on a Cartesian plane, so remember our x is their b, so this would be the b, and then our y is the a. So my x-intercept is 18, so you can put 18 right here. And then my y-intercept is 3, so it's 1, 2, 3. Okay, the dots. And then let's just, yeah, this is your, let's see, let's test each one. If A is less than 3, so A is your Y value, less than 3, that means 2, and B below, B is positive. Not always, because if you go from negative 1, the B value will now become negative. So that can't always be true. What about B? If A is less than 1, here's locate 1, 2, 1. So that means 0 and B below. So when if A is less than 1, B is negative. Yes. Wait, is that right? Wait, let's look at A again. If A is less than 3, if A is less than 3, so that means 2, 1 beyond below, B is positive. So- Oh, it is true. Okay, so you look at this graph. It's A. So if A is less than 3, so that means when A is 2, 1, 0, -1, -2, etc., B is positive. Yes. So if you look at 2, the B value is positive. If you look at 1, the B value is also positive. If you look at 0, it's positive. Even if at -1, the B is still positive, right? -2, the B is positive. So it's definitely A. That was a tricky one. Let's do 25. So 25 solve for y. Yeah, there's no, what I would do is just cross multiply. Um, you could, yeah, because it's only two sides, you can cross multiply. If there's more than that, you would have to get rid of the denominator, right? And wait, I'm gonna check if I can reduce anything. No, 9/5 cannot be reduced. So you just go ahead and cross multiply. So this is gonna be 9 times 9y minus 6 equals to 5 times 16y plus 5. So if I FOIL this out, 9 times 9y is 81y. 9 times -6 is -54. 16. So what's 5 times 16y? That is 80y. What's 5 times 5? 25. Okay, go ahead and solve for y. So I'm going to subtract 80y. So this cancels. So you get 1y minus 54 equals to 24. Add 54, you get y equals 54 plus 25 is 79. Letter A. Okay, not too bad. A few more to go. Yeah, I know it's impossible to. You have to do all this in like 33 minutes. And but I'm taking my time because I want to show you all the steps. It's 26. 26 says evaluate when VI is 60, A is 6, T is 7.5. So they want to find out what VF is. Okay, so this one's not too bad. You just plug in your value. So VF is a V1, which we said was given as 60, plus AT is A times T, so it's 6 times 7.5. So when you put it all together, oh, without a calculator, remember we can't use a calculator, so what is 6 times 7.5? So it's like 7.5 times it by 6. So 6 times 5 is 30. Carry the 3. What's 7 times 6 is 42. 43, 44, 45. How many decimal? That's 1, so that's 4, 45. And then you could do this on a scratch piece of paper. 60 plus 45 is 105. Okay, that would be letter D. 27. So what is isolate C? So this one's not too bad. You can do this, right? So we have E equals M times C squared. And I want to solve for C. So first thing is I get rid of this M by dividing both sides by M. So you get E over M equals the C squared. And then to solve for C, you're going to take the square root of both sides. So C is going to be square root of E over M. So letter A. 28. Okay, 28. Here we have a system of equation. We want to know the correct one. So we have 4x plus 4y equals 4, negative 3x minus 5y equals negative 7. What I would do is you could graph each linear line, right? You could do that. Or what I would do is just find the point of intersection or the solution. That would make your life easier, and then that would be your answer. So let's find the point of intersection or the solution. And how do we do this? By doing elimination. So what letter do you want to get rid of? Really up to you. There's no easier way. Let's get rid of the x's. So you have a 4x and a negative 3x. So the common denominator would be 12. You just make one positive 12 and the other one, I mean 20. Actually, let's get rid of the y's. So yeah, 4y, negative 5y. You just make one positive 21, 20y, and the other one negative 20y. So I'm going to make the top positive 20y by multiplying the first equation by 5. And then I'm going to make this negative 5y into a negative 20y by multiplying both sides by positive 4. Okay, so when you do that, you're going to get 5 times 4x is 20x. And then 5 times 4 is 20y. And then 5 times 4 is 20. And then do the bottom. What's 4 times negative 3 is negative 12x. And then 4 times negative 5 is negative 20y. And then 4 times negative 7 is negative 28. Okay, add them up. Well, 20x minus 12x is 8x. The y's cancels, that's what we want. And then what's 20 minus 28? That is negative 8. Divide this by 8. Divide this by 8. You get x equals negative 1. So you have an x coordinate of negative 1. And then how do you find the y coordinate? To find the y coordinate, you can plug in negative 1 into either this one or this one. As long as it's original. Do not put it here because you multiply that by 5, and do not put it here because it's also not original. So I'm going to put it here. So it's 4 times negative 1 plus 4y equals. Okay. 4 times negative 1 is negative 4 plus 4y plus 4, and then add 4 to both sides. So you get 4y plus 8 divided by 4. You get uh, 8 divided by 4 is 2. Okay, so your solution is negative 1, 2. So which one is that going to be? Negative. So which one of these graphs has a point of intersection at negative 1, 2? Letter D. So if you look at this -1, comma 2, that's the point of intersection, so that is the solution. At 29, um, which of these graph represents a following table? Which of the graph represents a following table of values? So we have, let me go scroll down. Our C coordinates are -15, -5, 5, and 15. My F coordinates are 5, 23, 41, 59. So which one of these? Is it A? So the x-axis represents C. The y-axis represents F. So is the first one, is it a -15, you'd have a y value of 5? Nope. A -15, it looks like has a y value of like 55. So it's not A. B, B is just way off. It doesn't look right at all. It's, no, it's not B. C, it's also way off. Look how they labeled the x-axis. The x-axis should not be here, it should be down here. So it's not C. It must be D because if you look at the coordinates, at the x value, C, -15, it spits out a y value of +5. So is that true? Here's -15. Yes, that's true. So it's going to be D. Yep, all you get, that's all you got to do. 30. Um, Consider the following formula, 3D equals E minus 3. So I have a feeling that this is a linear line. Yes, it is a linear line. So if it, when you're dealing with linear, you just got to graph it. That's just easier. So what do I do first is solve for D because it's like y. So you get rid of everything by, let's get rid of this 3 by dividing everything by 3. So you get D equals, um, E over 3 is the same thing as 1/3 E. And then -3 over 3 is -1. That's much better. So it looks like our Y is our D, and it looks like our X is our E. Okay. So how do we graph this? We know that the y-intercept is -1. So you have a y-intercept at 0, comma -1. And then what's the x-intercept? You replace D with 0. Um, so that's going to be, oops, 0 equals E, E over 3 times 1. And then get rid of the fraction. So you're going to multiply everything by 3. So you get 0 equals to E minus. And then you solve for E by adding 3 to both sides. And you get E equals 3. So if you graph it, it works. What do we say our x? Our x's are E, so this is E. Our y is D. So let's see here. Blah, blah, blah. My x-intercept is +3. My y-intercept is -1. There's our graph. So now what we're going to do is test each one. So let's see if A is right. If D is less than -1, so D's are Y value. If D is less than -1, so here's -1. So anything below -1, like -2, -3, E is positive. That is definitely false, right? Here's if D is less than negative. So if you do -2, oh wait, that is not true. -2, what's the E value or the X value? Positive. -3, positive. Positive, 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 right? So I think that is the choice. Wait, E is less than -1. Oh, no, that's wrong. I was looking, so this also, if you extend this, I made a mistake. So at -2, the E is negative. At -3, the E is negative, so it's not A. What about B? If D is greater than -3, um, here's -3. If D is greater than -3, E is negative. No, that's not true. So if you do -2, it it becomes negative. But if you go above, it starts to become positive. So it's not B. What about D? If D is greater than -1, so here's -1, and if E is greater than negative, so that includes 0. So 0, what is the E value? Positive. What's the E value 1? The D value is 1, positive. And then if you go beyond, it's going to start becoming positive because this extent. So I think the only one is always true, C. 31. This one you just plug in, and you'll get your answer. So they're saying A is 24, B is -2, C is 4, D is -3, E is 7, and G is 3. You want to know the J value. So there's no isolation because J is already isolated. You just plug in your values. So A is 24, B times C, so it's B is -2, so it's -2, and then C is 4. The pencils kind of, yeah. And then it's going to be -3. And then A minus C is 24 minus C minus 4. And then it's E plus G, so that's 7 plus 3 equals to J. Okay. So when you put it all together, you get 24 divided by -8. And then this is the 80. Oh, this is a minus 3, so that becomes a positive. So it's 3 times 20 over 10 equals J. Okay. So when you clean this up, 24 divided by -8 is -3. 20 times 3 is 60 divided by 10, that's 6. And then that gives you J. So what's 6 minus 3 is 3. So it is D. Okay, I think this is the last one. So isolate n. So x equals 9 over 9 plus 1 over 3 n minus 3. So we gotta isolate n. So what would I do? But first, maybe yeah, do not get rid of the fraction. I tried doing that first and made it much more complicated. Instead, I would subtract 9 from both sides. So I get x minus 9 equals, and then you're left with the fraction of 1 over 3 times n minus 3. Okay. And then what I would do is clean the bottom. It's 1 over, just FOIL out this 3. So this is going to be 3n minus 9. And then you have x minus 9, 1, cross multiply, that's 1 equals. So it'd be x minus 9 times 3n minus 9. Then I would get rid of the x minus 9 by dividing both sides by x minus 9. So my pencil's like dying. So we're left with 3n minus 9 over 1 x. Okay, and then I'm going to add 9 to both sides. Add 9 to both sides. Okay. So I have, we put it here, have 1 over x minus 9 equals 3n. And then the last step is to get rid of this 3 by dividing both sides by 3, everything by 3. This is where it gets a little bit tricky. So this becomes n. 9 divided by 3 is 3. What about this? This is a complex function. If you want, you can rewrite this as 1 over x minus 9 divided by 3 over 1. If I cross multiply, this is going to be 1 over 3 times x minus 9. Yeah, my pencil's just dying. So it's going to be, it's going to be letter A. Okay, letter A. Okay, last one. Yeah, I have to stop here. Do one more. Or zero. That's it's solve for x. So this one's not so bad at all. What I will do is subtract 7 from both sides. You get y minus 7 equals to parentheses x minus 4 squared. And then to solve for x, you're going to get rid of the power 2 by taking the square root of both sides. You get the square root of y minus 7 equals the x minus 4. And then solve for x, so you're going to add 4 to both sides. 4 to both sides. That's not a y, it's 4. And you should get letter A. I mean, not letter A. It's letter B. Square root of y minus 7 plus 4. This is, yeah, it's 4. So letter B. Okay, we will stop here. Yeah, we'll stop here.